Good evening to all. So today we have to be discussed the subject electronic devices and circuits. So this is very important subject for ECE students. So today we have to talk about the semiconductors. When we are talk about semiconductors, we must know the idea of conductors and insulators. So the subject name is electronic devices and circuits. So what is conductors? So it can allow the conductivity. What is insulators? It opposes the conductivity. So among these conductors, semiconductors, insulators, which one is popular? Semiconductors are very popular these days. So what is semiconductor? What is semiconductor? At low temperatures, at low temperatures, semiconductors behaves like a insulators. Semiconductors behaves like a insulators. At the temperature increases, at the temperature increases, the same material behaves like a conductors. The same material behaves like a conductors. So it possesses both conductors and semiconductor properties. So those are called semiconductors. So among conductors, semiconductors and insulators, so which one is popular? So semiconductors are popular. Why? Because we can control the semiconductors. How we can control the semiconductors? Semiconductors can be controlled by when the light fall when light fall, the conductivity controlled by light fall. When temperature varying, it will be controlled. When we apply electric field, when we apply electric field, so we can control doping concentration. When we vary the doping concentration, conductivity will be changed. So doping concentration. Among these all are controlled with semiconductors. But what happen in conductors and insulators? So only they can allow the conductivity and oppose the conductivity. So these two activities are due in conductors and insulators. But in semiconductors, it can be controlled by when the conductivity will be controlled by light fall, temperature, electric field apply, doping concentration vary, the conductivity will be changed. So we know very well the equation of RT is equal to R naught into 1 plus alpha T. So when temperature increases, what happen? The resistance will be increased. So this is alpha is the temperature coefficient of resistance. Alpha is the temperature coefficient of resistance. In semiconductor, current is due to both electrons and holes. In semiconductor, current is due to both electrons and holes. What are the currents in semiconductors? The currents in semiconductors are two types of currents are there. Those are in semiconductors. There are two types of currents are there. Those are diffusion current, diffusion current, drift current. Diffusion current and drift current. So in conductors and insulators, only drift current is there. In conductors and insulators, only drift current is there. So in conductors and insulators, only drift current is there. In semiconductors, both drift and diffusion currents are there. So we have to see, we know very well. So atom consists of electrons, neutrons and protons. What is atom? Atom is a invisible particle. So atom is a invisible particle. Electron, proton having equal and opposite charge. Neutrons has no charge, so atom is electrically neutral. Neutron has no charge, that's why the atom is a electrically neutral. So compared to electron and proton, we preferred electron because electron mass is less. Compared to proton, electron mass is less. So how much it will be less? So 1 by 1836 of the proton. So that's why we preferred electron. So we know very well atom is a invisible particle. So that atom consists of protons and neutrons. So that's why we will be take a charge of positive. So electrons revolve around the nucleus. Electrons revolve around the nucleus. So here the electrons are there in the orbit. Okay, so here this consisting positive charge and this consisting negative charge. Why it will be fall into the nucleus? At the same time, why this nucleus will not attract to the electrons means in between here the Coulombic force is acted, and opposite way centrifugal force will be acted. So that's why electrons revolve around the nucleus. Revolve around the nucleus in a circular or elliptical manner. So what is the maximum number of electrons in the orbit? So the maximum number of electrons in the orbit is 2n square. The maximum number of electrons is 2n square. So what is the charge of electron? The charge of electron is 1.602 into 10 power minus 19 coulombs. So here electron charge of electron is 1.602 into 10 power minus 19 coulombs. So when the current will be flow? So when it is in bounded electron, it will not flow any current. When it become a free electron, so that then current will flow. When it will become free electron. So when we want to, this electron will be become free electron, some energy is required. So that energy is called ionization potential. That energy is called ionization potential. So so this is the nucleus. Electrons revolve around the nucleus. We want when the current will flow, this electron will become a free electron, current will flow. When it will become a free electron? When we use some energy in the orbit. So we become a free electron, the current will flow. That energy is called ionization potential. The energy required to make the outermost orbit electron has a free electron. That corresponding energy is called a ionization potential. What is ionization potential? The energy required to make the outermost orbit electron has a free electron. That corresponding energy is called a ionization potential. So, when the current will flow, this bounded electron will become a free electron. The current will flow. When it will become free electron? When we apply some energy and we remove this electron from orbit, so that electron will become a free electron. So that energy is called ionization potential. Okay, how much energy is required to become a free electron is minus 13.6 by n square electron volts. Suppose it is in first orbit. The hydrogen atom, how much energy is required to become a free electron? For example, the question is the hydrogen atom to become a free electron, how much energy is required? So this is 1 square. So that's why it is minus 13.6 electron volts is required to become a free electron. So here in formula, what is there? Minus 13.6 n square electron volts. So electron volts is the units of energy. Electron volts is the units of energy. One more units are there for energy. What is that? Joules. Joules are also the units of energy. So when we use electron volts and when we use joules, so electron volts is used for small quantities measured, we use the electron volts. When large quantities are used, we use the joules. So what is the relationship of, for example, suppose we want to move near distances, we have to say in feet. Suppose we want to go Hyderabad like that, we will tell the kilometers. So depending upon the distance, we have to be change the units. So that's why the small quantities measured, we use electron volts. So large quantities we measured joules. So what is the relationship of joules and electron volts? 1 joule is equal to 1.602 into 10 power minus 19 electron volts. 1 joule is equal to 1.602 into 10 power minus 19 electron volts. So, in atom, electron revolve around the nucleus. It will be become a free electron. We have to be apply some energy, ionization potential energy. So the electron will come and here. After that, some that energy is not there. What happened? This electron? This electron will not stay in between bounded electron and free electron. It may be a free electron or bounded electron. It will that is called forbidden gap. That is called when it become a free electron. So that band is conduction band. This electron will not stay in between of valency band and conduction band. So this is called forbidden gap. So this one is called forbidden gap. This one is called forbidden gap. Okay. So this electron will maybe a stay in orbit or it may be a become a free electron. It will not stay in between, prohibited, forbidden gap, not allowed. So this is also called prohibited. It will not stay in the middle. So it may be a valency band or conduction band. So that is called forbidden gap. So silicon atom, silicon atom, forbidden gap at room temperature. Forbidden gap at room temperature is 1.1 electron volts. Suppose it is a germanium atom, forbidden gap at room temperature is 0.72 electron volt. So the size of the atom is given by the, what we had we discussed. This is the atom or electrons are revolve around the nucleus. How can you find out the size of the atom? The size of the atom is given by 0.529 n square angstrom. So 1 angstrom. So angstrom is length units. 1 angstrom is equal to 10 power minus 8 centimeters, or when we want to say in meters, so that is 10 power minus 10 meters. So here the size of the atom is given by 0.529 n square angstrom. 1 angstrom is equal to 10 power minus 8. So here what is the differences of conductors, semiconductors and insulators according to energy band diagrams? So see here. So what is the differences of conductors, insulators and semiconductors? So what is the difference of conductors, insulators and semiconductors? We know very well. So conductors are overlap in energy band diagram. The conductors are overlapped. In insulators, so there is no energy gap in between valency band and conduction band. Suppose it is insulators. So this is the valency band. So this one is the conduction band. In between, so it consisting, so this is conduction band. So this one is valency band. It consisting 6 electron volts. What is the energy gap of valency band and conduction band in semiconductors? So this is 1 electron volts. For this semiconductors and insulate semiconductors, conduction band, valency band. So here the energy gap in semiconductors is 1 electron volts. Suppose when we use the material is silicon, how much energy gap? It is a 1.1 electron volts. Suppose it is a germanium, how much it is? 0.72 electron volts. So which material is called semiconductors? So which material is called semiconductors? Fourth group of elements. So fourth group of elements, we call it as a semiconductors. So fourth group of elements means valency 4 electrons. Which one consisting valency 4 electrons and covalent bond nature is there. So that is called semiconductors. So Semiconductors means valency 4 electrons means this is the atom in nucleus. So here the first orbit it consisting 2 electrons. In second orbit 4 electrons are there. 4 plus 2 6. So atomic number 6 is carbon. Carbon is a fourth group of element. So atomic number 6 carbon. So just like so next orbit it consisting valency 4 electrons. So that element is silicon. So that element is silicon. So for that next orbit is germanium. So for that next one is tin. So next orbit it consisting 4 valence electrons lead. So these are all are the fourth group of elements. These all are the fourth group of elements. So carbon, silicon, germanium, tin and lead. So how much energy is required? What is the energy gap for this? So silicon is 1.1 electron. So germanium is 0.72 electron volts. So for tin is zero point 0.1 electron volts. So here carbon acts as a insulator. So that's why it is a 6 electron also. So carbon is very tightly bound to the nucleus. Carbon is very tightly bounded to the nucleus. So that's why it is a it required more energy. So carbon will be acts as a insulator. So tin and lead will be have the properties conductor properties. So these two are used as a semiconductors. These two are used as a semiconductors. So lead consisting very less energy to become a free electron. So we know here the carbon has different forms available. Carbon available in different forms. Carbon availability in different forms. Those are diamond, amorphous powder, amorphous powder, graphite. Graphite. So diamond will be acts as a insulator. Graphite will be acts as a conductor. Amorphous powder will be acts as a semiconductors. So in germanium and silicon, which one is popular? In germanium and silicon both are used as a semiconductors. Which one is popular? In germanium, silicon. Silicon is more popular. Why? Because silicon has temperature withstanding capacity is more and it is very easy to affiniated with oxygen. And it is very easy to affiniated with oxygen. So what we have to be earlier discussion is true energy band diagrams. What are the differences of conductors, semiconductors and insulators? Okay. So here what are the examples of conductors? Copper, aluminum, gold, silver, etc. So same way, what are the examples for semiconductors? Silicon, germanium. What are the examples for insulators? Paper, mica, glass, etc. Paper, mica, glass, etc. So in conductors, what is the temperature coefficient of resistance? So this one has positive temperature coefficient of resistance. So this one has positive temperature coefficient of resistance. This one has negative temperature coefficient of resistance. insulator has negative temperature coefficient of resistance. How can we say this one is positive temperature coefficient of resistance? This one is negative temperature coefficient of resistance means, so we know the formula RT is equal to R naught into 1 plus alpha T. So here what happened when temperature increases, resistance is increases. When temperature increases, resistance increases, the current will be decreased. So this is called positive temperature coefficient of resistance. This one is called positive temperature coefficient of resistance. So here how can you say negative temperature coefficient of resistance? RT is equal to R naught into 1 minus alpha T. So when temperature if increases because of negative value, the resistance, so this value will be decreases, resistance will be decreases, current will be increases. So this one is called negative temperature coefficient of resistance. Negative temperature coefficient of resistance. In conductors, it is a positive temperature coefficient of resistance. So we know very well in semiconductors are two types. Semiconductors are two types. Intrinsic semiconductors, extrinsic semiconductors. Okay. So intrinsic semiconductors means pure semiconductors. Intrinsic semiconductors means pure semiconductors. So in intrinsic semiconductors, we have to see the structure for that. So in this pure semiconductors, in this diagram what it shows to us is pure semiconductors. In silicon has 4 valency electrons, so completely bounded with remaining all. So when we have to see that one, pure semiconductors, what happened? So this fourth group of element, silicon, will be will have 4 valency electrons, will have 4 valency electrons. This will be bounded with another electrons. So that bonding will be like this. So what happened? It will be bounded. So in pure semiconductors, so it will be completely bounded with another. Okay. So now we want to, so it is stable, it is stability, neighboring neighboring silicon atoms like this. Okay, so current here is 0, bounded electron become free electron, then current will flow. So here the current is 0, this bounded electron will become free electron, then current will flow. So some energy is required to jump this electron from valency band to conduction band. So here in pure semiconductors, energy band diagram, the conduction band. So this valency band is completely filled with valency electrons. In this, it will be completely filled with valency electrons. When we have to give some energy, this electron will jump from here to here, so that will become a free electron. Jump valency band to conduction band, that will become a free electron, and hole will be created. So in this way, what happened, hole will be created. So here also, when it become a free electron, what happen? Hole will be created. What is hole? Hole is a absence of electron. Hole is a absence of electron is called hole. Absence of electron is called as hole. Okay. So after some time in intrinsic semiconductor, number of electrons is equal to number of holes. So that is N is equal to P is equal to intrinsic concentration. So electron travel sometime. So electron travel sometime in conduction band. After afterwards what happened? It will fall in, afterwards it will fall in valency band. So it will be combined, so it will be combined in whole is called as recombination. Electron travel sometime in conduction band, afterwards it will fall in valency band. Combine it whole is called as recombination. So what it is called as recombination. So here, when the electron give some energy, first of all, there is no current will flow. So after some time, when you are giving some energy, electron become a free electron. After some time, this electron fall into the valency band. So that is called recombination. That one is called recombination. Hole is called absence of electron. Hole will not move. So for example, you take one bench. When you are sitting in this bench, suppose you are a electron, you will go somewhere, that place is called hole will not move, some other electron will come and sit in that place only. Okay, so here when it recombine, some heat is produced. When the material used, germanium and silicon, heat is produced in p-n junction diode preparation. When we use silicon and germanium, so recombination time heat is produced. Okay, suppose you are using gallium arsenide, gallium phosphide, gallium arsenide phosphide, like that, the light is produced. In that place, the light is produced. Okay, so here in this intrinsic semiconductors, N is equal to P is equal to Ni. So N is equal to P is equal to Ni. Electron generation to recombination time is called lifetime period. Electron generation to electron generation to recombination. Electron generation to recombination time is called lifetime period. So in sometimes in examination they are asking, in intrinsic semiconductor current is due to electrons only, holes only, both electrons and holes 0. So at that time what is the answer? In intrinsic semiconductor current is due to both electrons and holes. So now extrinsic semiconductors. Extrinsic semiconductors. So we know very well extrinsic semiconductors are two type, N type and P type. Why we go for this extrinsic semiconductor? Germanium and silicon are the pure semiconductor. Conductivity practically not sufficient. To increase the conductivity, we add some impurities to the material. So that is called doping concentration. Okay, so when we add the impurities, that is called doping concentration. Then it is called as a extrinsic semiconductor. Germanium and silicon are the pure semiconductors. The conductivity practically not sufficient to us. So when we want to increase the conductivity, we add some impurities to the material. Some impurities to the material. So that is called extrinsic semiconductor. So when we are adding 1 into 10 power 7 atoms, the conductivity will be increased 1000 times. The conductivity will be increased 1000 times approximately. So doping concentration increases more and more, conductivity also increases more. Adding of impurities to intrinsic semiconductor, that is doping the material is formed, is called extrinsic semiconductor. So when we add some impurities to the material, that is called extrinsic semiconductor. To add the impurities is called as doping. So that is called extrinsic semiconductors. Extrinsic semiconductors are two types, N type and P type. N type and P type. So these two are very very important. So here N type and P type. So what it is, when we call it as N type, by doping with fifth group of elements, doping with fifth group of elements, doping with fifth group of elements. Those are, for examples, phosphorus, arsenic, antimony, bismuth. So when doping with fifth group of elements is called as N type, doping with the third group of elements, doping with the third group of elements is called as P type materials. So examples are boron, aluminium, gallium, indium. Gallium, indium. So come to the energy band diagram. Come to the energy band diagram for this N type material. So this is the valency band. So this one is conduction band. So valency band is completely filled with valency electrons. Okay. So completely filled with valency electrons. See the structure for that. See the structure for intrinsic semiconductors. Already we draw it. Yes. So see here. So this is intrinsic semiconductor. In this, so we want to add a fifth group of element phosphorus. We want to add fifth group of element phosphorus. So what happened when we are adding the fifth group of elements phosphorus? So here the outermost is 5. 1, 2, 3, 4. Fifth group of elements. Valency of electrons is 5. So now if you want to bring this electron outside, if you want to bring this electron outside, how much energy is required? So only 0.05 electron volts is required. 0.05 electron volt is required because energy why this one is required very less energy means you see it is loosely coupled, not for in tightly coupled. So this is the separately is there. It is not created whole. So when we will be remove this one, it will not created whole. It will be created a positive charge. So what happened here? So it will be in 0.05. So what happened here? So here the electrons already when we are given energy, some electrons will be jump, and at the same time the distance is very less, electrons also jump here to here. So what happened in n type majority carriers are electrons. Majority carriers are electrons. Minority carriers are holes. Minority carriers are holes. Okay. So how much energy is required? This electron will become a free electron. So 1.1 electron volt is required. This bounded electron become a free electron. This loosely coupled electron will become a free electron. It required 0.05 electron volts. So that's why very easily jump the electrons from here to conduction band. So that's why the in n-type material, the majority carriers are electrons, minority carriers are holes. Here also electrons, and already when we are given some energy, here also electrons are there. So that's why in n-type semiconductor material, so the majority carriers are electrons, minority carriers are holes. Suppose it is a p-type material. Suppose it is a p-type material. So suppose it is a p-type material, you have to be taken as boron. So you taken as boron. Third group of elements means, so third group of elements. What happened? Here only outermost has 3 electrons. Here it is ready to accept. So it needs 1 electron. Okay. So what happened? It needs some electron. So at that time it will be jump from here to here. So here already when it will be jump here to here, some holes are created. Here also holes will be there. So in p-type semiconductor material, the majority carriers are holes. Minority carriers are electrons. So whenever the bonds broken, electrons jumps holes created. So the impurities added, energy gap of holes is very less. So that's why the majority carriers are holes, minority carriers are electrons. So here we have to be observed in n-type material, how many electrons are there? That positive ions are there. That count of positive ions are there. In p-type material, how many holes are there? That count of negative ions are there. Negative ions. So these are the immobile ions. These are called immobile ions. So here the differences of n-type and p-type semiconductor materials. So by doping with fifth group of elements, so it will be form a n-type and p-type semiconductor materials. The examples of n-type is phosphorus, arsenic, antimony, bismuth. The examples of p-type is by doping with third group of elements. By doping with third group of elements. So what happened? Here this has majority carriers are electrons. Minority carriers are holes. Minority carriers are holes. The same way here the majority carriers are holes. Minority carriers are electrons. Minority carriers are electrons. The charge of n-type material is electrically neutral. The charge of n-type material is electrically neutral. So here, how can you say the charge actually when electron jump from here to here, the positive hole will be created. But here we should not tell like that. The charge of the charge of this is very important. The charge of n-type material is electrically neutral. Same way, p-type material is electrically neutral. How it will be means, so when it is in fifth group of elements, phosphorus, what happen? It will be bounded. Some electron is there. So when it will become a free electron, so it will become a free positive ion. So it will become a, so this all are become a positive ion. So ions are immobile. These charge carriers are called Nd plus donor ions. These charge carriers are called donor ions. Nd plus. Same way here also charge of p-type is electrically neutral. So this is called Na, acceptor ion. This is in p type, it is called acceptor ion. In p type, it is called acceptor ion. So n type material popular than p type material because conductivity is due to the electrons. It has higher mobility than holes. So that's why we preferred n type material. So next one is mass action law. In case of extrinsic semiconductors, number of electrons and holes product is equal to Ni square, square of intrinsic concentration. So that will be Ni square, square of intrinsic concentration is equal to E naught T cube e power minus Ez naught by kT, Boltzmann's constant temperature. So here this one is the material constant. So this one is the material constant. So this is the temperature. So this is energy gap at 0 degrees Kelvin. This is temperature. This one is Boltzmann constant. So intrinsic concentration depends on material constant and temperature. So n-type material increases doping concentration, the number of electrons increases. When n-type material increases the doping concentration, the number of electrons will be increases. Temperature constant, minority decreases. Finally, what happened? The product is constant. So, finally, the product is constant. So, N into P is equal to square of concentration, square of intrinsic concentration. At thermal equilibrium, doping is increased. Majority carrier concentration, doping increases. What happened? Majority carrier concentration increases. Majority carrier concentration increases. So minority carrier concentration, what happens? Decreases. So the product is constants. So this is the mass action law. In intrinsic semiconductors, N into P is equal to Ni. So mass action law is equal to N into P is equal to Ni. In intrinsic semiconductor, N is equal to P is equal to Ni. In intrinsic semiconductor, N is equal to P is equal to Ni. So in mass action law, N into P is equal to Ni square. So now drift current and diffusion current. Drift current and diffusion current. Drift current and diffusion current. Before going to discussion drift current and diffusion current, we must know the definitions of electrical potential and electrical intensity. Then only we are able to understand the drift current. So, what we know the definitions for electrical potential. Electrical potential V. So, same way electrical intensity E. Okay. So what is this electrical potential? This is work done. This one is force. So the energy required, suppose positive unit charge. So this is the unit charge. So this one is field. Energy required to bring this unit charge. Energy required to bring this unit charge from infinite distance, that corresponding energy level is called electrical potential. So energy required to bring this unit charge from a infinite distance, that corresponding energy level is called electrical potential. Force required to bring this unit charge is called electrical intensity. So here force and work done. What we have to be mentioned the names force and work done. What is the force and work done? Work done is equal to force into displacement or distance. Displacement or you have to be mentioned distance. So what is W is equal to force into distance. So the potential V is equal to electrical intensity into distance or displacement. The potential V is equal to electrical intensity into distance. So small voltage of dV is equal to small distance of x dx. So what is the electrical intensity? Electrical intensity is equal to dV by dx. So this is volts. So this one is distance, means volt per centimeters. So sometimes electrical intensity is equal to minus dV by dx. When it is minus dV by dx, sometimes electrical intensity is equal to negative potential gradient. So here voltage means electrical potential and electrical intensity are the same. Electrical potential and electrical intensity are the same. So one is energy and another one is force. So what we have to be discussed here, electrical potential and electrical intensity. So that electrical potential and electrical intensity are the same. So one is for energy and another one is for the force. So here diffusion diffusion current. So this will be helpful for drift current. Now diffusion current. So diffusion current. So we have n type material. Suppose we have a one n type material, means it is completely filled, so it has some electrons. We have some electrons. We have n type material. The number of electrons means doping concentration is high. Move one place to another place. It will be move one place to another place without any electrical field is called diffusion current. So here, what is diffusion current? Without any electrical field, the movement of charge transportation, charge carriers, higher concentration to lower concentration. That type of current is called diffusion current. Higher concentration to lower concentration. The type of current is called diffusion current. So this diffusion current is not depends on electric field. So it will be independent of electric field. Which then with dependent in the, it depends on concentration gradient. It will be depends on concentration. It will be depends on concentration gradient. So easily, how can you understand? Means suppose okay, one sponge is there. In that you have to be pour the one drop of ink. What happen? After some time, it will be spread along with the sponge, isn't it? So that is concentration gradient. So means here that will be transportation from higher concentration to lower concentration. So how much it will be spread is the, that is called diffusion current. For example, you have to be take water, one glass of water. In that you drop, you have to pour one ink drop. What happened? It spreads throughout the water. So that is called diffusion. It will be spread after some time, it will be spread throughout the water. That is called diffusion. So now drift current. What is drift current? So drift current means, so you have to be give some electrical intensity. So that's why we discussed. So drift current. So when we give some electrical intensity, n-type material positive charge, negative charge. Due to electrical intensity, force attract the electrons. Force attract the electrons, that current will takes place. So drift velocity is proportional to electrical intensity. So drift velocity is equal to mobility of electron. Mobility of electrons. So Vd is equal to mu into E. So here mu is the mobility. Mu is the mobility. So mu is equal to drift velocity by E. So what is drift velocity? So meter per second or centimeter per second. What is E? Volt per meter. What is the units of this? Mu is equal to meter square by volt second, centimeter square by volt second. So type of mobility depends on type of semiconductor or nature of the material. Mobility depends on temperature, and also mobility depends on electrical intensity. Mobility depends on electrical intensity. So this is the diffusion current and drift current. So diffusion current means, when we have n-type material, the number of electrons move one place to another place. The number of electrons to move one place to another place without any electric field is called diffusion current. So when we are given n-type material positive charge and p-type material to negative charge, due to electrical intensity, force attract the electrons. Due to that, current will take place in drift current. So in drift current, Vd is proportional to E, electrical intensity. Vd is equal to mu E, mobility. So at the same time, what is mobility? Mobility is drift velocity by E. So here, what is the units of drift velocity is meter per second or centimeter per second. So finally, what is the units of mobility? Meter square by volt second, meter square by volt second, uh, or suppose we want to say in centimeters, centimeter square by volt second. So here mobility depends on type of semiconductor or nature of the material. So same way mobility depends on temperature, mobility depends on electrical intensity. So today class, what we have to be discussed for this. So what are the differences of conductors, semiconductors, insulators according to energy band diagrams? What are the semiconductors? How many types of semiconductors are there? N-type semiconductors, P-type semiconductors. So see here, N-type semiconductors and P-type semiconductors. So completely we have to be discussed those differences and mass action law. After that, drift current and diffusion current. So we will be continue the next class.